Hello, students and lazy chemists. Welcome to the lab that we have here that's going to be on the pressure temperature dependence of a gas. And in this lab, what we have is we have our methodology and we had our way of measuring it here. Okay. Now, in the lab that was originally given to you, you were supposed to have a gas syringe. However, we ended up plugging in a pressure sensor instead, and that was more so because the gas syringe didn't actually work all too well. So what we are going to be doing here now is going to go ahead and talk about the information that we got from the lab and how we can go ahead and analyze it here. Now, in the lab, what would have happened was that I gave you a whole series of numbers, and I have a whole series of numbers right here. One was the temperature, and one was the pressure. And there was one thing in particular that I wanted us to take note of, that as the temperature increased, so did the pressure increase. Therefore, we can go ahead and track specifically what happens when we get a pressure of 0, at what temperature that is, okay? And so that's what this is asking us to do right here, okay? And what we'll do right here is go ahead and take this and transform the data. And this is going to be a transforming of the data in the term that the final exam is going to want you to go ahead and examine it. So let's go ahead and start with that right here. This is going to be one that we use. In this case, I'm going to go ahead and use Google Sheets here. And all that I've done here is I've made a column and I've made temperature C, because that's the measurement that we have. And then we have pressure in kilopascals because that's what we measured it. I put in my temperature, so my different temperature values. I put in my different pressure values. And we can go ahead and hit chart right here, okay? And our chart, it originally gives us a line, but we are never going to want a line, okay? We are always going to want to change it over to a scatter plot. And how we get a line is going to be a little bit different here. So first we're going to go ahead and customize, and let's see, I believe it's series first, okay? So series first, what we're going to do for this one is we're first going to go ahead and customize our dots. And theoretically, if you were doing this all officially, you should be using the color black. And then you are also going to go ahead and use X's. Okay, you can use X's or crosses. We don't have any cross mark here. So we're going to use X's officially. Okay, that's our official one. Again, when you turn this in as a lab report, I'm all right with you guys using blue though. Okay. Then we're going to go ahead and mess with the next thing on our graph, which is talking about specifically the x-axis and the y-axis. Now our y-axis, that can stay exactly the same because that's dependent upon what we're changing. However, we need to change our x-axis, and a reminder that our x-axis is this one right here. So it's going to be our horizontal axis, okay? And we need to change that so that it has a negative 300 value. And our maximum value needs to be 100. And we get that specifically from the lab report, okay? So this lab report says that we need to have negative 300 and 100, okay? And notice that we're going to be crossing a 0 mark here, okay? If you do click out, you can hit here and then edit chart. Go back to customize. And after we've made our chart, inputted our data, now we can go ahead and move on to the next part, okay? And the next part is to produce a line back to the value where the pressure is 0, okay? So we're going to be making a line, And realistically, what would happen is that if you were making this line, you would go ahead and just try and make a straight line. So you would use a ruler to make a straight line that went through and passed through as close to those points, those data points, as possible. Okay? So your goal would be to make a line that passes as close to all the data points as possible. We get to have an easier time with this when we go and use it in Google Sheets or something like this. We can use what's called a trend line. Okay, and this trend line essentially is going to do all of the work for us. Okay, our trend line though, we will want to change the color. We don't want to have it as the same color. So we're going to change our trend line here to be red in this case. And this shows us our trend line specifically of when pressure equals 0. Okay? And we see here that it looks like the pressure equals 0 at, probably negative 260 or something. Okay? So we have our trend line. Now let's go ahead and take a look back here. And temperature when volume is 0. Okay? So we're going to have two kinds of answers here for this one. First of all, we're going to have the scrub answer, okay? And the scrub answer is going to be the person that's like, okay, well, let's take a look at this, and that's about negative 260, okay? Okay, that's the scrub answer. Just saying like, it's close enough. We don't need to measure it, okay? We don't want to have the scrub answer, okay? In order to figure this out, all that we would have to do is use the fact that this is a line, okay? And the line, if we wanted to, we can go ahead and figure out, based off of a couple of points on the line, what our slope of the line is, and then figure out the long way there, okay? Or, since this is a computer program, we can also grab the equation for the line, okay? So under series and then trend line, you can go ahead and use equation, okay? And this equation is our formula for this line. Now a reminder here that the formula for a line is y equals mx plus b. Here we have m times x plus b, okay? So we can go ahead and take this equation for the line of 0.355 times x plus b, and let's go ahead and move to the front and put y equals, okay? And now we have y equals mx plus b. Okay, so therefore, we can go ahead and now mathematically figure out our question. Okay, temperature when the volume is 0. All right, well, we know that we're looking for 0 equals 0.355 times x plus b. Okay. We need to go ahead and get x all by itself. Well, actually, we can input the number for b. That is 91.6. Okay, so now we have this. We'll go ahead and move the 91.6 over. 91.6 equals 0.355 times x. 91.6 divided by 0.355 equals x. And then we just have to actually do the math there. And I'm tired, so we're going to go ahead and Control B. And it looks like our answer that we get here is 258.028. Okay. So our answer our non-scrub answer is 258.028. Okay, then we have to go ahead and take a look here. And that's our figured answer. Okay, and it looks like from our line equation we ended up using 3 digits in our line equation, so we'll want to have 3 digits total. So we'll have 258. Okay. Now what it's asking for is it's asking us to figure out our absolute temperature. Okay. Oh, and we can't forget the negative, and we can't forget our units, of course. All right. Now it's asking us to go ahead and calculate our error. Okay. Now our error is going to be the one that uses the equation of measured minus expected, and all of that is going to be divided by our expected. Okay. So our measured temperature in this case was negative 258 minus expected. Now this means that we have to go ahead and take a look and see, all right, when is this expected? Okay. When would we expect to have absolutely zero pressure for a gas? Okay. And this is a gas that has nitrogen, it has carbon dioxide, it has all sorts of things in it. And since it has all of these gases in it, it's even going to include things like it's going to have some helium in there. It's going to have all sorts of gases. So what we're actually looking for is the point and motion that all gases would completely stop, and that there would be no movement in this container. Okay? Now, no movement means that there's no average kinetic energy. No average kinetic energy is actually absolute zero. Okay? So that means that we would have to look back and see, okay, what is the temperature of absolute zero? Okay? And that was one way, and that was the way that I was hoping many would find out. But I figured that most people would say, what is the temperature at which the pressure of an ideal gas reaches zero? Okay. And it's going to say absolute zero. And in this case, it's negative 273.15. Okay. So we'd go ahead and take 258, negative 258, minus negative 273.15. Okay. And then all of this is divided by, and we're going to add extra parentheses here just to make it so I can lazy it up. Okay. Negative 273.15. Okay. Copy. Paste. And it looks like this experiment here gave us negative 5.54% error. Okay. So our percent error is going to be equals to negative 5.56%. Okay, so we have a negative 5.56% error. We'd go ahead and put error here. All right. Next here, it's asking for us to go ahead and say what other things or what other sources in the lab could have caused errors. And we're talking just, sources other than the fact that, this is equipment issues. And it's wanting you to go ahead and think, okay, well, let's take a look back at this lab. What are some factors that might affect it? Okay. Is it possible that the initial temperature that Mr. Bradley did it might affect it? Is it possible that there's some pressure left over from the hose itself? What is an ideal gas? And were the gases that were in there an ideal gas? Okay, so those are all like different questions that you can go ahead and answer in there, and that would help to give, show that you have a little bit more understanding for this particular problem. Okay, this one right here, this is, basically a new vocab. And this last one is just writing a law, or writing something that you guys see is happening here for it. Okay? And I'd like you to actually pause here for just a moment to think. Most laws are going to be, how do you relate pressure and temperature together? Or how do you relate one thing to this other thing? One of the most famous laws that we know of is E equals mc squared. And that's basically saying that energy equals mass times the speed of light squared. Okay? And that's just a direct relation. This law is saying that we have pressure is equal to some constant. Okay? It doesn't matter what. And whenever you see K, just think some constant times temperature. Okay? So it just basically means, hey, there is a relationship between these two. Okay? And usually, you would want to go ahead and put these two on the same side. So pressure and temperature equals a constant. And that would be the best way to go ahead and write that there is a relationship here. And if you even put this law into Google, you'll find the gas laws. Okay? And this particular gas law is what's known as Gay-Lussac's law, where the pressure and temperature are related to one another. Okay? Now this is going to go ahead and close us down for this section here. And I hope that this helps to explain the lab and makes it so that you guys understand it just a little bit better. A reminder that you guys can go ahead and use this now to finish up the lab, and I hope you enjoyed it and that you find some satisfaction in figuring out that you were able to determine the temperature of absolute zero. Till the next time, hope you have a good one, and remember, be lazy.